everyone, my name is Assylbekova Ayaulym and my teammate Nurpeissov Alisher, and welcome to our video when we are going to talk about our article that called Active Learning Strategies and the Teaching in Data Science and Artificial Intelligence in Higher Education.
To keep things smoothly, we're going to follow a clear 5-part structure. We're going to start from the introduction, move into the literature review, cover the methodology, break down findings and analysis, and finally wrap up with the discussion and conclusion.
Alright, section 1, Introduction. As the data science and artificial intelligence become increasingly important in higher education, universities are expected to prepare students not only to understand theoretical concepts, but also to apply analytical, computational, and problem-solving skills in realistic context. The key point is that the AI students are not preparing for isolated technical work. In real careers, these students are always connected to other fields. That's why students need to be flexible, interdisciplinary, and able to communicate, collaborate, and make justified decisions. This paper examines how active learning strategies support the teaching of data science and artificial intelligence at the university level.
This is defined as a student-centered approach where learners construct knowledge directly through problem-solving, inquiry, and practical application. It's an idea deeply rooted in constructivist learning theory. So instead of knowledge being mechanically transferred from a teacher to a passive student, like taking notes, students actually build their understanding through hands-on experience. In this model, the instructor is more like a designer of learning environments, a facilitator, rather than just a traditional lecturer.
So, the crucial point is really understanding the difference between these two approaches. On the one side, we have traditional lecture-based instruction, and sure, it's useful for introducing basic concepts, but it relies on the passive reception of theory. Of course, it's just insufficient for building deep analytical competences, but on the other side, we have constructive active learning. This is all about hands-on practice. It builds higher-order thinking, evaluation, and collaboration skills. In fields like data science, where you absolutely must understand not just what an algorithm is, but when, why, and how to use it.
Moving on to Section 2, Literature Review. Let's look at the theoretical foundations. Here we examine how foundational research backs up the integration of these active methodologies into technical fields. Higher education demands that students develop independent thinking, right? Synthesizing these key scholarly findings builds a really rigorous academic justification for what we'll see in the data later. For instance, research by Prince back in 2004 and Freeman and colleagues in 2014 shows massive empirical support for active learning improving performance across STEM and engineering courses. This empirical support is so critical right now because the sheer complexity of modern tech demands proven methods. Fast forward a bit, and Cardova's 2024 review found that problem-based and gamified learning drastically increases student motivation in computer science. And then Kong et al. In 2022 highlighted that combining flipped classrooms with project-based learning doesn't just build technical skills, it actually fosters ethical awareness, which is a huge necessity in modern AI education.
And this breakdown brilliantly illustrates how specific strategies map perfectly to the unique demands of data science. A flipped classroom frees up valuable class time for hands-on practice. Project-based learning builds that full end-to-end workflow competence. Collaborative learning directly mirrors the real-world teamwork required in the tech industry. Gamification drives motivation for repetitive, sometimes tedious technical practice. And AI-supported feedback provides immediate, on-the-spot support for debugging and self-regulated learning.
Okay, Section 3, Methodology. So how exactly did we gather data to validate all these theories? Well, we utilized a descriptive research design, combining a review of recent literature with a targeted survey of individuals directly involved in higher education tech courses. The survey was given to a sample size of exactly 100 participants. These individuals completed a 5-point Likert scale survey, ranging from strongly disagree to strongly agree. And that's a vital methodological choice. A Likert scale captures the nuanced spectrum of human experience when grappling with complex AI education, giving us much more rigorous and reliable data than a simple yes or no questionnaire.
The sample included 80 students and 20 instructors or professors. This means that data mainly reflects the students' experiences. while still including valuable inputs from teaching staff who design and deliver these courses. The main course areas were machine learning at 48%, artificial intelligence at 37%, and data science at 11%. Some extra data about our survey. The findings supports our argument about students that need to be more flexible in their interdisciplinary career, and that active learning supports this because it gives more real problems. Okay, let's go deeper. Practical tasks and project-based learning were the most strongly represented strategies, while gamification was less central. This shows that these AI courses focus more on authentic real-world work than on surface-level engagement. Respondents also agreed that active learning helps connect theory with real applications. This is important because future ML and data science specialists will need to work across domains, understand context, explain their choices, and adapt to different problems. At the same time, the results show that this approach is challenging. Active learning requires more preparation time, fair group work management, more complex assessment, and clear rules for using AI tools. These challenges matter because interdisciplinary AI work is complex by nature. Therefore, active learning should be carefully structured to build both technical competence and professional flexibility.
Finally, Section 5, Discussion and Conclusion. Let's talk about recommendations for higher education. Based on this robust survey data and literature review, what are the actionable takeaways? We outline 5 key recommendations for higher education. Step 1. Always integrate authentic datasets to show the practical value of the methods. Step 2. Make project-based learning a core semester-long component, not just a rushed final assignment. Step 3. To combat those group work challenges we just talked about, structure collaborative learning with strictly defined roles and peer evaluation. Step 4. Require transparent documentation from students when they use AI-supported feedback tools. This protects academic integrity. And step 5. This is a massive shift from traditional grading. Assessment rubrics must align with workflow reasoning and communication, rather than just mechanically grading a model's final mathematical accuracy. Now, to maintain rigorous scientific integrity, we must impartially report the limitations of our study. First, a descriptive design captures perceptions, but it does not directly measure long-term skill development or actual grade improvements. Second, the study relies entirely on
The survey also exposes a massive paradox. While active learning looks flawless on paper,
Third,
dropping
as
it
we
into an
emphasized
actual
earlier,
university
the sample
creates
size is a
intense
much
friction.
favored representation of student perspectives compared to instructor views. Therefore, we can suggest that our future research should really focus on measuring the specific, quantifiable impacts of these active learning strategies on actual student performance metrics. To conclude the analysis of our paper, we want to leave you with a provocative thought to really chew on. As AI tools rapidly evolve, becoming better and better at writing code, analyzing data, and solving complex problems, how will academic institutions balance their undeniable values on-demand learning aids against the emerging of the very real risks to academic integrity and independent student reasoning? It is a delicate tightrope that the universities will have to walk in the coming years. Thank you for your attention.